Ever wonder how scientists can talk about something as massive as a galaxy or as tiny as an atom without filling up entire blackboards with zeros? Well, they use a kind of mathematical secret code. It's called standard form, and today we are going to crack that code together.
Seriously, have you ever been writing out a huge number and felt like you're just drowning in zeros? You count them, you lose your place, you count them again, and you're still not sure you got it right. It's a total pain.
I mean, just look at these. Writing them out like this is not just awkward, it's practically begging for a mistake. One little slip up with a zero, and your whole calculation is completely wrong. So yeah, that's the big problem, right? All those zeros. They're clumsy, they're confusing, and honestly, they just get in the way. Surely there's got to be a smarter way to do this.
And of course there is. What if I told you there's a system that can take these long, messy strings of numbers and squish them down into something clean, compact, and way easier to work with?
Well, say hello to standard form. This is the elegant solution we've been looking for. It's how scientists and mathematicians handle the biggest and smallest numbers you can imagine, and we're going to dive right in.
So what is it exactly? It's actually beautifully simple. You just take any number and you rewrite it as a value that's between 1 and 10, and then you multiply it by 10 to a certain power. That's it. That's the whole idea in a nutshell. Okay, let's start with the giants, the really, really big numbers. How do we use standard form to wrangle them and make them more manageable? Here is the golden rule. You take the important digits to make a number between 1 and 10, and then you figure out the right power of 10 to make it all equal out. Let's actually see how that works. Let's try it with 320,000. So first step, we use the digits 3 and 2 to make our number between 1 and 10. That gives us 3.2. Easy enough. Now for the tricky part. How many times would we have to multiply 3.2 by 10 to get back to 320,000? Well, you can think of it as counting the hops the decimal point makes. From 3.2, it has to hop 5 places to the left to get to 320,000. So that 5 becomes our power. And voila, you get 3.2 times 10 to the power of 5.
All right, we've tamed the giants, but what about the really small stuff? The microscopic numbers. How does standard form handle numbers that are less than 1?
You'll be happy to know it's almost the exact same process. There's just one crucial little twist. Instead of a positive power, we're going to use a negative power. Okay, let's take 0.004. The only important digit here is 4, right? So that's our number between 1 and 10. Now, how many places does the decimal point have to hop to the right to get from 4 all the way back to 0.004? Let's count. 1, 2, 3 places. Since we're moving right to make the number smaller, our power becomes -3. So we end up with 4 times 10 to the power of -3. So here's a quick way to remember it. For big numbers, you're using a positive power, which represents the decimal moving to the left. For small numbers, you're using a negative power, which represents the decimal moving to the right. That's pretty much the whole game. Okay, so why are we doing all this? I mean, besides looking neat. Well, this is where standard form shows off its real superpower. It makes doing complicated math shockingly easy. So imagine your teacher asks you to solve this without a calculator. All those zeros. It's just a minefield, right? It looks like a huge headache. But now let's convert it to standard form. That messy problem turns into this. Instantly, it just looks cleaner, doesn't it? It's so much less intimidating. And here's the magic. We can just split this problem into 2 easy chunks. First, we deal with the numbers, 2.8 divided by 1.4. Then we deal with the powers, 10 to the 6th divided by 10 to the 4. And look how simple the answer becomes. 2.8 divided by 1.4, that's just 2. And when you divide powers, you just subtract the exponents. So 6 minus 4 is 2. Our final answer is 2 times 10 to the power of 2. Or, just 200. Way easier. So let's just lock in the most important things to remember. Standard form is always a number between 1 and 10 times a power of 10. If that power is positive, you're dealing with a big number. And if that power is negative, you know you're working with a teeny tiny one. And just like that, you now have a tool that lets you write down the biggest and smallest things in the entire universe with total clarity and confidence. So the only question left is, what are you going to measure next?